Hey guys, hope we're doing well today. This is continuance off the last video in module 6, device boxes, same objectives. Should be able to size and install outlet boxes after this lesson. Should be able to identify the appropriate box size and type for any given application, most given applications. Okay, so we went over last video extension rings. Let me get my pointer out here. So we went over extension rings. We went over raised industrial covers. We went over the difference in the raised part. This is for drywall. This is finished look. Now what we're going to go over after I get this erased is we're going to look at extension rings. So extension rings are boxes, essentially for your boxes. So per se, we have an octagon box. It has a back, right? This box is to contain splices. Can be used for different things. Mainly being an octagon box, this is used for lights, light fixtures, light box. So if we need to extend this out, say this is up in the ceiling, our drywall's down here, or up a little, up a ways where we got to extend it out. They make extension rings. See how this doesn't have a back? Same thing. Almost look the same if you don't know which one's which. This extension ring, as you can see on the inside, has 2 holes. Lines up with these. So these 2 holes go onto these holes. See how that works? So in turn, this would fit right onto there in these screw holes, just like that. I know my video is little and you guys can't see that very well, but you can see inside of there, the screws go in. Then you have this for an extension ring. It brings you down closer to ceiling height where your screws are long enough to get in there. This can also be used to add depth. So it would actually add more volume inside your box. So for different codes and stuff like that, that we'll get into. So the next thing, as you can see, this drawing is in your book. It is on page, let's look it up real quick. I just exited out of my thing and I need. So let's put that back. Messed that up good. Anyway, so in your book, module 6, open to module 6. I can see 9, 8, 7, module 6. I get to module 6 and I am on page 9. Page 9, module 6. You can see this chart or this photo tells you different things. What switches count? 1 switch as 2 conductors. So with this picture, there's a conduit, we know, coming into this box. Let's look at this one. This is a different box we'll go over in a minute, but there's a conduit that comes into this male adapter, also known in general as a connector. The conduit runs down, comes into the box. Inside that conduit, there is a code for how many wires can fit in here, okay? For the number of wires per volume on this conduit, which we're going to go over down the road. So it's a max fill. So as many as you can put in that conduit, you can fit into this box. That is not true. So as many as you can fit into this conduit may not work in this box. So you got to go with your minimum number of conductors on your whole system. The whole raceway is what we call it, path. So even though I can fit X amount in the conduit, maybe my single gang small box or round octagon box won't hold that many conductors. With that being said, if that box is going to hold a light switch, we would automatically, from the max number this box will hold, if there's a light switch going in it now, not just a blank cover, we will subtract 2 conductors per switch. So that's what this chart is showing you, what we would subtract. It shows you what we'd subtract for a receptacle, 2 conductors per receptacle. Based on the largest conductor size. So if you have a number 12 and a number 14, we know the white wire that we've used Maybe we haven't used it yet, but it's smaller in diameter than the 14, smaller in diameter than the 12 AWG, American wire gauge. So we'd go off the 12 because it's the larger volume wire. We would subtract 2 conductors based on the largest conductor connecting to that device. So tells you clamps, all kinds of different stuff. This is all available in your code book for reference. Use your code book for reference always. NEC section 314.16B4. So we will use that. That'll give you switching. It looks like 314.16B is going to give you most of these codes. So this also goes over if there's a conduit coming into this box, but then running out at a 90-degree angle. So here, and your wire is going to go, let's turn it this way. Your wire is going to come in the box and go down through this conduit. It talks about conduit running through the box counts as one conductor. Since there are 2 conductors shown here, these conductors count as 2 conductors. 2 conductors. So it gives you the different velocity, size for how your wires run, and what deductions must be made for different types. Okay, so we go on. Items that may be discarded when calculating outlet box capacity. So your ground, let's go back here. I think it gave us a ground, yes. So on your ground, get an eraser here maybe. That's not what I wanted to do. Eraser, okay, not worried about it. So here it shows multiple grounds. These look like they're all to be the same size, but you would always go off the largest conductor. Although several equipment grounds, see how there's several grounds going through here, all in this wire nut. One's landed to here, one to here, one to here. It's all spliced and runs through. All those several equipment grounding conductors are shown. They count as only one conductor, and that's based on the largest size. So if you have a 12 and a bunch of 14s, the one conductor that counts is the 12, the volume of the number 12 AWG. That goes on for any size from whatever to whatever. So 18, 16, 14, 12, 10, keep on going, 10 for 30 amps. So then you go to number 8, you look in your ampacity chart in your code book, it lists all the wire and all the amperage. So depending on what your amperage your device pulls. Again, getting ahead of myself. So grounding conductors count as one, the largest grounding conductor. Items that may be disregarded when calculating outlet box capacity, which is what we're doing. Don't let me confuse you with all the other stuff I'm talking about. We are counting the capacity of the outlet box. Items disregarded when calculating box capacity include grounding clips, no deduction. Grounding screws, no deduction. Wire nuts, no deduction. Cable connectors, no deduction. Pre-wired fixture wires. So this is a fixture that's already wired inside the device. It's not pigtailed here like we would normally do. Those would count as conductors, spliced conductors. These are already pre-wired. So all they are is the volume of what needs to go into here. So don't count them. Pigtails, it says, does not count. So when we pigtail this, when our white's here and our black's here and we land them on the screw on the light, those won't count. Don't deduct them. Determine the size of an outlet box, NEC table 314.16. I can tell you all day how to do it in this or walk you through step by step. You need to learn how to do it on your own in NEC table 314.16B. Installing outlet boxes. Now we get into a whole nother story. So with installing outlet boxes, there's several rules in the NEC code, how far they need to be apart, how high they need to be off a counter, all kinds of different location rules. So when you're installing the outlet boxes, they must be correctly sized and listed for the application. Conductors must be protected against abrasion. And the box must be supported properly. We went over supporting boxes to studs and in spreader brackets. Boxes must remain accessible for future repair and maintenance. If your wire is too short, if you're working in a house where they had issues, I come across this all the time, where people have made a splice in a wall. You can't have an open splice that's not in a box. So one, you can't splice it if it's not in a box. Two, you cannot cover up any box with any box period in a wall. You have to have access to every box. So if I need to get a wire down a wall, it's not long enough, that's already in there, there's nothing I can do. I'm not going to go over every scenario. I'm going to have to cut a box in, splice that in a box, come out of there and go down to where I need to go to my outlet box or switch box or whatever it may be. That splice has to be accessible. It has to be cut in. Every splice, every accessible means of wiring. So anytime that you strip a conductor, things like that, you have to have access to it. This also goes to the requirement for receptacle locations and dwelling units. This is listed in NEC code section 210.52. You will need to know that, especially in residential applications where you're doing this on a daily basis. So receptacle mounting. Heights may be varied to suit the building use and structure. If there's a countertop running across here, obviously they don't want this, or they may not want this under the counter. So this is going to have to move up here at the counter height. See how good of a picture I can draw. You guys know me and my pictures. Oh yeah, so there it is. So obviously that would have to move up to counter height. 15 inches from finished floor. If you can find this in the code book, what this inches is, what this is supposed to be, the exact code of from the floor to the bottom or even to the top or to the middle of the outlet, what it is supposed to be, I will pass you for this course. So preferred height, 15 inches. That's preferred for some. Others, I mean, it's just going to vary. So switch height. Face plates should completely cover the wall opening. When you cut your hole in, they make different sizes of face plates from, let's just call it XL, it's called oversized, to small, to your little metal plates that I showed in the last video. It's got to be a real tight opening. They're smaller covers. So you want to make sure that you cut your box in so it fits in there tight. You want your box to fit tight on all four edges. That way you know your cover is going to fit in through the opening. Dimensions, when you read your blueprints, we've done a little blueprint work to this point. When you read those, it's going to usually give you, if it shows, let's say, there's got to be a way I can erase this. There we go. Working on it, guys, working on it. Those could have stayed, it don't matter. Okay. Let's get the pen back out. So it's going to show this drawing and it's going to look like this, right? That's a single gang receptacle. It's going to show that on the blueprint drawing. And then usually you're going to have a idea of how far it is on the floor, kind of like this. It's going to say 15 inches. If it doesn't say that on your map or drawing, sorry, blueprint, print, whatever, building plan, it may have it in the footnotes. It may say every outlet in building room A is 15 inches off the ground. So that is going to be preferred by the customer. Okay, so avoid installing receptacles where they will cross the boundary between wall finishes. Correct. So you do not want to have to make this work on a finished wall and on a finished tile wall. Drywall and tile, this is a pain. You'll have to cut covers, you'll have to modify it. I've ran into where it's had to be done. You don't want to do it, that's for sure. Usually your under cabinet, above countertop outlets are going to be in the backsplash. this shows one that is more correctly installed for this picture, this photo, this example. So you may have one sort of like this, but you're going to have cabinets here usually, or a mirror if it's a bathroom. Yeah, so you want to make sure that you're here. This is your safe spot right here. This area on your backsplash is safe. Put your outlets. Gaps and openings around outlet box must be repaired. So it wants it to be tight here all the way around. You want to make sure they're repaired. All surface be repaired prior to installation and receptacle cover face. Yes, you want that to go. Installation to avoid interference with the installation of the other systems. Right. You don't want, it says right here, no greater than 1/8 inch. You want to make sure that you're cutting your boxes in tight. Sometimes you're going to run into, God forbid, but you're going to run into a drywaller that could care less about your outlet box after you did a rough-in. You're going to get back there and things are going to be cut, covered up. Maybe they routed around your box after they put the drywall up and they cut into your wires. You want to make sure and tuck them way back nice and neat, out of the way. Make sure they're all tucked into your box when you do your rough-in, because they will get cut. The other thing is you want to make sure that your boxes are out and make that drywall protrude. They're out at the right surface level with your stud when you mount them, because if you set them back real far or something like that, that drywaller could just go right over them and forget to router that one out. Had it happened, I had to, my box was out the right distance, but I had drywaller that just didn't care. I had to make several trips back to a residential house wire just to find boxes. Funny part was, I'll give you a little story behind that. I got a call back. Customer was very upset with me. Things weren't working. The drywall was already up. Customers are a little more stressed out during a big job like that, a whole house wire where they're trying to get moved in. They've been through this whole process and now we're down to the paint and everything else, and they got outlets that aren't working. I was able to drive right out to that job, look around the room, take my screwdriver, and poke a hole right in the wall, right where the box was. Because I know what height I go off. I keep unless customer prefers different, it's always the same for me. I know the height, I know how far apart my outlets are on one wall. I'm able to do things like that because I'll go through before insulation and take videos of the room. That way I know where my rough-in is. I know where my wires run in the wall in case something gets cut while they're hanging the drywall. I mean, being prepared is very important. They have these codes in place for a reason, and these are the minimum. Always remember the NEC is the minimum. You can always go above and beyond and be more of a craftsman. This is the minimum, okay, to keep you from cutting corners, to keep electricians from making a larger profit and cutting corners in a dangerous way. You want to make sure that you follow the NEC code as closely as possible. Use it for a reference. It doesn't tell you how to, it tells you why to, okay? You want to make sure and use it as a reference. You have to know how to, okay? So let's go back real quick. Let me see what I missed. As the openings buzzing around the box, they might cover it up. If you do the same thing and you know yourself and you're a craftsman and you work in the trade and you understand how things work and you use the NEC code, you're going to be able to cover yourself and know that you did it right. And when you get back to that job, it's not going to be your fault. I mean, it happens from time to time, but if you do it right, you'll know. That's very important. So make sure that you're covering your own butt as well as keeping your customers safe. So back, I skipped one there. Wire nuts. Wire nuts are color coded for different sizes of wires. Usually it says on them. If not, it says on the package. It will tell you what they can be used for from 18 to number 10. And then it'll tell you it'll hold this many 18s under one wire nut. It'll hold this many number 10s. You want to follow the manufacturer's information when installing the wire nut. So make sure that you know you're going to get in a groove where you know what colors do what color sizes do what. Of course, there's blue small ones here. I can usually use with 18, 14, thermostat wire, things like that, all the way up to these reds that I use with number 10 from time to time. Rarely will I use it with a number 8. might, I don't know. I think they go up to number 8, but these light blue looking ones are actually tans. They look a little different in the picture. They're tan sized wire nuts, I believe, unless they are blues, large blues, they may be. So it just depends on the size. You're going to get to know when you see what wire nuts you prefer, what sizes you need to use without looking it up, without reading the manufacturer's information. But until you get to that point, make sure you're reading what size wires they'll go from to. I mean, you've got to know that. So you don't want to try to shove 2 wires in a wire nut that's too small. You're not going to have a good connection. I'm not even going to get started on connections, but a not good connection will kill somebody. We'll burn their house down. We'll take their livelihood from them and everything they've earned or collected and all their memories. Make sure you're using the right sizes. Make sure you're reading. It takes no time. Usually you're getting paid anyway. Take the time. So stripping tools. Make sure to choose the correct tool for the size. The wire sizes are wrote on here. This one says it'll strip number 10, number 12, number 14, so on and so forth. You want to make sure you're using the right one. Otherwise, you can scar the wire. If you scar the wire, the copper wire, you go, or aluminum, whatever it may be, the conductor, you go to put the wire nut on, you're twisting it hard, getting a good connection because we like good connections because they're safe. Next thing you know, wire breaks because you scarred it. Scarred drywall and pop it. You know how a scarred drywall piece works, it breaks. Copper, aluminum, things like that. Good conductors are usually the same way. If you scar them good all the way around, twisting the wire nut on real hard, you're going to break them. So if you're not using the right size here, you're going to have issues. You don't want to have issues. Again, take the time. You're getting paid. Usually it's by the hour. Some of you may end up making salary. I don't know. But if you're on salary, it means that you're probably pretty good at what you're doing and you've taken the time to get there. If you're getting paid hourly, it doesn't matter anyway. There's no excuse, regardless of what you're getting paid or what you're doing, not take the time. Take the time, do the job right. Make sure you're using the right groove. I know it's easy to get in a groove and just start stripping stuff and just pay attention. It takes the biggest safety issue is time, trying to rush through things. Stripping insulation is typically stripped back about a half an inch roughly. I use my thumb sometimes. I'll strip it out the length of my thumb, the tip of my thumb. I know I can get a good connection there. You're going to have your rule of thumb, so you go by what you think. Wires installed in wire nuts. Turn the wire nut until the conductor is fully sealed in the wire nut. You're going to get a good feel for it. It takes a long time. It takes a lot of connections. In this class, that's one reason why, and hear me now, I make you do it over and over again. That's one reason why we're stripping wire out and just throwing it out and using new wire once it gets so short, because we've cut it again and again, because I want new connections every time. I want you to know your connections are good and tight. I want you to start getting a good feel for those wire nuts. It's important. It is very important. To become a good electrician, you've got to know. You've got to get a feel for it. So that's very important. Even if you're just doing this in the future for yourself and taking this class as an elective, you don't want to be putting your wire nut on and one, you strip the wire, you use the wrong thing so it's nicked. 2, you didn't twist it. 3, you're just putting the wire nut on there and it's not a good connection. You got all kinds of weak points all of a sudden. You're calling a guy like me, somebody's calling a guy like me to come fix it, and that's why we make the big bucks, because we go do it right. It's repaired. So that's the important thing. Okay, guys, that is the end. We have one more video for this section we will be going over, so I'll see you soon. As soon as I figure out how to stop recording.